Here's integrated 3. It's chapter 11. It's 1.1.1 lecture, and it says, how can 1 be useful? So basically it's talking about giant ones, if you remember that from other classes that you've been in, and we're going to learn how to simplify rational expressions. So I'm just going to do, in your book, I think I'll just, that's my dog playing, sorry. I'm going to do 11-3 and 11-4 and 11-5. So 11-3, it has, it says, use what you know about the number 1 to rewrite each expression below in an equivalent, simpler form. State any values of the variable that need to be excluded. So x squared over x squared, you guys remember that? Oh, well, I didn't do letter A, but you guys know that anything over itself is 1, and we write it, sometimes they write it as a giant 1, like that. We like to use those for canceling stuff out in fractions. So I'm just going to do letter C. So letter C said it's x minus 2 over x minus 2. Well, those cancel out over x plus 5, x minus 1. So you'd cancel that whole thing out. See, these cancel out. And then your answer would just be x plus 5 over x minus 1. Now, this one, they're asking us to state any values of the variable that need to be excluded. So we can't have 0 denominators. So here you would have a 2 would make a 0 denominator, and here a 1 would make a 0 denominator. So I'm excluding 1 and 2. So this one I had k times h times k all over h. Sorry, all over, it's letter E. I had h times k over h. So I canceled out my h's because those are a giant 1, and then I just had hk. And h can't be 0 because that would have made a 0 denominator. On this one, you can see that I have this times this, and this times this. Like there's 2 factors on top and 2 factors on the bottom. These factors are the same, so I could think of them as a giant 1, and I cancel them out. And then I'm just left with what's left. 2m minus 5, 3m plus 1. I excluded negative 6 because that would 0 this denominator, and I excluded negative 1/3 because if you plugged it right there, it would 0 this denominator. Okay, letter G started out like this. It had 6 times n minus 2 squared over 3 times n minus 2. Well, I rewrote that as 6 times n minus 2 times n minus 2 because that's what n minus 2 squared is. And then I decided that I could, these are all factors now, and so I decided I could cancel out the n minus 2, and I could also cancel out the 6 and the 3 because 3 goes into itself once and it goes into 6 twice. So then I'm left with 2 times n minus 2. And then I excluded the value of 2 because it would make a 0 right here. This one, even though there weren't any parentheses, I mean, these look like add-ins, but since this whole thing matches exactly this whole thing, that's a giant 1. So I can cancel that out, and then I'm left with 1 over 4x minus 1. And that, I mean, I hope that you guys already know how to do this from your classes that you've had before this, but it's going to get harder in a minute, but just a little reminder that you can cancel out factors if they match. Okay, so and then right here, if I plugged in a negative or a 1/4 right here, that would 0 this out, so I have to exclude that value. And over here, 3/2 would 0 out this denominator. And if you don't know that by looking at it, you can write the factor equal to 0, and then you can solve it. Like I added 2x to both sides, and then I divided both sides by 2, and I found out that's how I got the 3/2, if you can't do it in your head. So that's 11-3. 11-4 says, Mr. Wonder now tries to simplify 4x over x and 4 plus x over x. Mr. Wonder thinks that since x over x equals 1, then 4x over x equals 4. Is he correct? Well, yes, he is correct, because these are factors. 4 times x, they're factors. They're not being added. They're factors. You can cancel factors, but not add-ins. And then the x over x is a giant 1. So you can plug numbers in to check. If I plug 1 in, 4 times 1 is 4, divided by 1 is 4. But if I plug 2 in, it should still work. 4 times 2 is 8, divided by 2 is 4. 4 times 3 is 12, divided by 3 is 4. Any number that I plug in for x, I'm going to get 4. So this one, I can verify that it's true. This one, letter B, it says, he also wonders if 4 plus x over x equals 5. Is this simplification correct? Substitute 3 values of x to justify your answer. So he thinks that maybe, I don't know what he thinks. Maybe he thinks these are a giant 1, and so 4 plus this giant 1 equals 5. But that's not really true. And you can tell by plugging some numbers in. First, you might agree with Mr. Wonder and say, oh yeah, 4 plus x over x is 5. You might agree, but then when you plug in your 1, 4 plus 1 is 5, divided by 1, that is 5. But what if you plug 2 in? 4 plus 2 is 6, divided by 2 is 3, not 5. So, that's why it's telling you to plug in some numbers. It said plug in 3 different numbers. So, let's see. 4 plus 3 is 7, divided by 3. Well, whatever that is, it's not equal to 5, is it? 7 divided by 3 is not equal to 5. So, and the reason that doesn't work is because this is 4 plus something. There's adding happening here. This one, you can cancel it because it's multiplying. You can only cancel things that are multiplying, not things that are adding. So when you multiply things together, that's called a product, or they're a factor and a factor and a product, right? So I can only cancel factors, not add-ins. These are add-ins, not factors. Okay, so, and then letter C says, compare the results of A and B. When can an expression be simplified in this manner? So I'm just saying you can only simplify factors, not add-ins. So you can't just knock this one out and this one out and say the answer is 4, or maybe think of these as turning into a 1, because these are, if I actually wanted to break this fraction apart, it would end up being 4 over x plus x over x. So it'd be 4 over x plus 1. So just be careful not to try to cancel out add-ins. So if you see a plus or minus, then just be very careful. So let's see what letter D says. Which of the following expressions is written correctly? So is this correct, or is this correct? So this one, it looks as though they thought it would be okay to just cancel out the x plus 3 and the x plus 3 and end up with x squared. Well, I'll tell you one thing. These are all being added together, not multiplied. So that's a danger. It's a warning sign right there. Now I can plug a number in there and see if this is true or not. Let's plug in, like, say 2. Okay, so if x was 2, then 2 squared would be 4 plus 2 plus 3. What did I say x was going to be? 2. 2 plus 3 is 5. 4, 5, 6, 7, 8, 9. So this is 9/5 over here. And I plugged in 2. And this is just 2 squared is 4. That's not equal. Okay, so you can't do it this way. You can't just these are being added together, not multiplied. Now, if I could factor this, and if one of the factors were x plus 3, then I could cancel. I tried factoring it. You can see I tried to see if I could find something that multiplies to make 3 and adds to make 1, but I could not find anything that did that. This one you can actually cancel out because this is like 1 times x plus 3, and these are both factors. And those actually do just leave, this is like a giant 1 times x plus 2, and the answer is x plus 2. And if you want to plug some numbers in, you can. You can say 2 plus 2, I'm going to plug in for x equals 2. 2 plus 2 is 4. 2 plus 3 is 5. 5. You can see those are going to cancel out. And then 2 plus 2 is 4. So do these cancel out? Yes, I get 4 equals 4. And if I tried plugging 3's in, the same thing would happen. I would get, you can try plugging a couple more values in. What we're trying to get to is to make you understand that since these are factored, since it's like something multiplied by something, that's when you can cancel. If it's just something added to something, you can't cancel. Okay, so, and then I'm going to try to fit 11 dash, oh wait, no, I'm not. I'm going to make a separate video for 11-5.